Q9076, which performance factor decreases as airplane gross weight increases for a given runway? A. Critical engine failure speed. B. Rotation speed. C. Accelerate stop distance. The correct answer is A. With an increase in weight, the critical engine failure speed, also known as W, rises, lowering performance. Q9085. Which condition has the effect of reducing critical engine failure speed? A. Slush on the runway or inoperative anti-skid. B. Low gross weight. C. High density altitude. The correct answer is A. Slush on the runway or inoperative anti-skid can have the effect of reducing the critical engine failure speed, V1. V1 is the speed at which the pilot must make a decision to either continue the takeoff or abort in the event of an engine failure. It is determined based on various factors, including aircraft performance, runway conditions, and obstacle clearance requirements. When there is slush on the runway or the anti-skid system is inoperative, the runway's braking effectiveness is reduced. This means that the aircraft may require a longer distance to accelerate to V1, as the tires have reduced traction on the slippery surface. As a result, the critical engine failure speed may be lower in order to provide an adequate margin of safety for the pilot to make a decision in case of an engine failure. Q9083. What effect does an uphill runway slope have upon takeoff performance? A. Increases takeoff distance. B. Decreases takeoff speed. C. Decreases takeoff distance. The correct answer is A. An airplane's rate of acceleration during the takeoff roll will be reduced by an uphill runway, which will result in it reaching its takeoff speeds, V1 and VR, later than it would otherwise. Some aircraft will also require a higher V1 speed while landing on an uphill runway. Q9075. Which condition reduces the required runway for takeoff? A. Higher than recommended airspeed before rotation. B. Lower than standard air density. C. Increased headwind component. The correct answer is C. An increased headwind component reduces the required runway for takeoff. Headwind is the component of wind blowing directly opposite to the aircraft's direction of travel. When there is a headwind, it effectively increases the airspeed of the aircraft relative to the ground. This increased airspeed results in a higher effective lift and a shorter ground roll, allowing the aircraft to become airborne in a shorter distance. By reducing the ground speed required for takeoff, the increased headwind component effectively shortens the required runway length. The headwind provides a beneficial effect on takeoff performance by assisting in achieving the necessary lift at a lower indicated airspeed, resulting in a reduced takeoff distance. Q9797. You are rolling out after touchdown and decide you really need to abort your landing and take off. Your airplane is at 116 knots and your engines have spooled down to 71% idle. You need a V2 of 142 to safely lift off and climb. The airplane will require 6 seconds to accelerate after the engines spool up to takeoff thrust, which requires 4 seconds. How much runway will you require for a safe landing abort from your decision point? Use an average of 129 knots ground speed. A. 1,738 feet. B. 2,178 feet. C. 3,601 feet. The correct answer is B. The inquiry makes the assumption that takeoff takes 10 seconds at a ground speed of 129 knots. Using a land speed of 129 knots, the distance needed to fly to the decision point would be determined. 1 knot equals 1.69 feet per second, or 218 feet per second. 2 lbx 10 seconds equals 2,180 feet.